Algebra 2, video 26.4. This is Mr. Mac. Hey, listen, on the last video, I kind of went old school, right? We're just kind of graphing it by hand. Well, today we're going to use that app I told you about called Desmos, all right? It's a free app. You can download it on your phone, and it absolutely is, I think, the best graphing tool out there, okay? Just to show you how easy this tool is, right here for graph 1, it's like a little red marble right here. All I had to do was type in y equals cosine of x, and that red marble means that they come over here and they draw the cosine of x in red, okay? And then you can go ahead and add more graphs and then you can compare it, okay? Look how much prettier that graph is from mine from yesterday, okay, or from the last video. All right, and look, it works. Here's 0 degrees. The cosine at 0 is 1. Look, the cosine at 90 is 0, all right? The cosine at 180 is -1, all right? The cosine at 270 is 0, and look, 360, you return back to 0 degrees, that's why it's the same value of 1. And just wanted to show you that when you get to that point where it repeats, all right, we call that a period of time, or a period, okay? So every 360 degrees, this pattern is going to repeat. Okay, I only went up to 720, all right, but 720 is 360 doubled. And if you notice, hold on, all right, and if you notice 360 doubled 720, look, you're back to 1 again. Okay, so your period of time. The formula for it is what we call 360 over b, okay? And b is going to be the coefficient of theta. Well, if you look at my first example, all right, the coefficient of x right here is an understood 1. So for this one, if I do 360 divided by 1, of course that's 360, we're saying every 360 degrees this pattern is going to repeat, okay, infinitely. All right, because it's a cyclic graph, okay? Are we okay with that? Okay, we're good? All right, so we're talking about period. Why don't we type in another one so we can show you how it affects it? So I'm going to come down to here, and I'm going to do the same thing. It's this simple. If you download this app, I mean, you are going to be absolutely amazed. So now I'm going to do the cosine of 2x, okay? All right, and if you notice, it's a blue marble, okay? All right, so the coefficient of x is a 2, so now I would do 360 divided by 2, and that gives you 180 degrees. We're saying that this pattern is going to repeat every 180, okay? So look at these points. Look, at 0 degrees, I'm looking at the blue one now. At 0 degrees, we were still at 1, okay? Then look, you go to 0, then you go to -1, then you go to 0, and look, at 180, now you're back to 1 and you're repeating, okay? So every 180 degrees, the pattern is repeating, and look at the difference between the blue curve and the red curve. Okay, yeah, it's kind of like a spring, right? And you're taking the spring and you're squeezing it together to create the blue one versus the red one. Okay, the red one, you've stretched the spring out. The blue one, you kind of push it together. Well, the period of time, again, is 360 divided by the coefficient of theta or x, and we're saying that the pattern is going to repeat every 180 degrees. Okay? All right, so let me take off that one. Actually, you know what? I can leave it, okay? Yeah, let me just go ahead and leave it. There's another thing that we want to talk about, and it's called amplitude. All right, let's look at the original red graph. And I'm sure by now you've noticed this, okay? Look, the highest value on that red graph is 1, okay? The lowest value is -1, okay? The amplitude for both of these is going to be 1, okay? All right, highest value is 1, lowest value is -1. and it ends up being the coefficient of the trig function. So look, if you look here where it says cosine of x, there's an understood 1 there. Cosine of 2x, there's an understood 1 there. All right, whatever's in front of your trig function, the coefficient, that a value, that is going to be your amplitude. It means it's going to run from positive a down to negative a. Okay, so in this example, if you look at both of them, even the blue one, even though we squished it together, look, the highest point is 1, the lowest point is negative 1. The highest point is 1, the lowest point is negative 1. So let me tell you what, let me back up and get rid of the blue one. Actually, you know what? No, maybe we'll leave both of them. I don't think it'll be too confusing. Yeah, let's do another color. Why not? All right, so I'm going to go y equals, and why don't we stick a 3 in front of cosine of x, okay? Here we go, cosine of x. All right, and then let me go ahead and erase this right here so you can see it. So look, both on the red and the blue, the coefficient of the trig function was 1, and so the amplitude was 1. Now look, my green marble, my green graph, there's a 3 in front of it, so the amplitude is going to be 3. The only thing different, if you take a look at the graph, is now instead of the highest value being 1 and the lowest value being negative 1, look, the highest value is going to be 3, and the lowest value is going to be negative 3. Okay, so amplitude is the coefficient of the trig function, and then the coefficient of x, or theta, if you plug it into this formula, 360 over b, that's going to give you the period. Here, let me write that a little bit neater, okay? So, given a trig function, it can be cosine, it can be sine, so I'm going to say y equals a cosine of b theta. You can also use x. If you want the amplitude, it's just the a value. Okay, if there's no number there, like in, look at the original red and blue one, there was no value there, so understood to be 1. Okay, look at the green one, there's a 3, the amplitude is 3. And then finally, for the period of time that your pattern is going to repeat, it's 360 divided by b. All you got to do is look at the coefficient of theta, it's right here, plug that into here, and that'll give you your period of time that the pattern repeats. Alright, if you take a picture of this, if you have this right here, you're going to be all set. It is good to see you, video 26.4, and guys, hang in there, okay? Hang in there.